dropped. A small pressure difference which causes flow of gas to take place is termed as draught. The function of draught in case of a boiler is to force air to the fire and to carry away the gaseous products of combustion. The draught may be classified as natural or chimney draught and artificial draught. Artificial draught can again be classified as steam jet and mechanical jet. Steam jet is induced or it may be forced. Mechanical draught is induced fan or forced fan, or it may be combination of these two. Natural draught. Natural draught is obtained by the use of chimney. The chimney in a boiler installation performs one or more of the following functions. It produces draught whereby the air and gas are forced through the fuel bed, furnace, boiler and settings. It carries the products of combustion to such a height before discharging them that they will not be objectionable or injurious to surroundings. Chimney. A chimney is a vertical tubular structure built either of masonry, concrete or steel. The draught produced by the chimney is due to the density difference between the column of hot gases inside the chimney and the cold air outside. This figure shows diagrammatic representation of chimney which is having a height h meters above grate level. This is the grate level. Here we have two pressures P1 and P2. P1 is pressure at the grate level, that is chimney side. This is the chimney side. And P2 pressure acting on the grate on the open side. This is the grate side and this is the chimney side. Here the pressure acting is P1, here the pressure acting is P2. The difference between these P1 and P2 or P2 minus P1, here the pressure will be more, here the pressure will be less. So this difference in chimney side and grate side will create flue gases to pass through this boiler economizer and finally through the chimney and to the atmosphere. This circulation of gas is caused by the difference between the pressure of this chimney and open side of the grate side. So this difference in pressure, we will call it as draught or pressure difference. This difference of pressure causing the flow of gases is known as static draught. Its value is small and is generally measured by a water manometer. This pressure in difference we will generally measure in terms of water manometer. It may be noted that this pressure difference in chimney is generally less than 12 mm of water. Here we have an expression for chimney height. If HW is height in mm of column of water which will produce the pressure drop delta P, then chimney height H can be calculated as follows using this equation. Now, how to calculate the chimney diameter using this formula? Then condition for maximum discharge through a chimney. At what condition a chimney will give you a maximum discharge? That can be calculated by using this formula. This difference is at this pressure difference H maximum, you will get a maximum discharge. Then finally efficiency of a chimney can be calculated using the expression which is given here, where all the term carries usual meaning. T dash is absolute temperature of flue gases leaving the chimney to create the draught of HW mm of water. T double dash absolute temperature of flue gas leaving the chimney in case of artificial draught of HW mm of water, and Cp is specific heat of flue gases. So using this formula with usual notations we can calculate the efficiency of a chimney. Here are some numericals I have solved the concept, and solution is also given.